For the demos in this module, I've created another app service in a new resource group. You know how to do that from earlier in the course, but I just want to point out that there's no app service plan in this resource group. And that's because I used the existing app service plan created earlier in the course, because it still has a lot of capacity. So you can put app services in different resource groups than the plan, and apply different access controls to each resource group. Let's close this, and back in the resource group, I'll click Create, so we can create an Azure SQL database. I'll search for Azure SQL, and click this. That brings up the different services available. We want Azure SQL Database. And we want a SQL database, and it's going to be a single database. On the Create screen, the resource group is already selected. Now, in order to host an Azure SQL database, you need a database server, which is a separate resource in Azure, kind of like the app service plan is to the app service. I don't have any database servers in my subscription, so let's create a new one. I'll give it a name, and this needs to be unique across Azure. I'll choose my local region. And for authentication, we want both SQL and Microsoft Entra authentication. That will allow us to use a username and password, as well as to set up a managed identity in Entra ID for the app service to access the database. You'll see that later in this module. I need to create a username and password for SQL authentication. And I also need to set an Entra ID account to be the admin. I'll choose my admin account that's stored in Microsoft Entra ID. And let's create this. Let's give the database a name. And for the workload environment, this will be a dev database. Now let's configure the database. For the service tier, we just want basic, because this is just a demo environment. I'll leave these defaults and apply. I'll select locally redundant storage, because we don't need our data backed up across zones or regions. This will keep it in a single data center, which will save us money, since this is just a demo environment. Now let's move to the networking tab. By default, there's no public access, but we want to enable public endpoints, which will set up some firewall rules. Unless you really plan to lock down your SQL server and want to create your own firewall rules, I suggest you enable to allow Azure services and resources access to the server. That'll allow App Service to connect to the database. I also want to add my current IP address to the firewall rules. That'll allow me to connect to the database from this VM, so we can see the database in SQL Management Studio. Next, on the Security tab, I'll leave the defaults. And on the additional settings, also accept the defaults. We'll skip tags, and let's create this database. It'll take about 2 minutes for the server and database to get provisioned, so I'll speed this up. And when it's done, let's navigate into the database. Here you can see the URL to the database server. And on the Connection Strings tab, there's a connection string here with the path to the server, the name of the database, and the authentication information for the SQL Server account we created when we set up the server. The password isn't included in the text here, so we'll have to enter that to use this later. But let's go back to the overview, and let's navigate to the SQL Server. This is where we set up security and access control. I'll go down to the Networking tab. My IP address was added to the firewall rules to allow me to connect from this VM. We're going to connect to the database using SQL Management Studio, which I have installed on my local virtual machine here. That's a free download from Microsoft, by the way. But first, let's get the URL to the remote database server in Azure. Now let's search for SSMS, which is SQL Server Management Studio. I'll paste in the URL to the remote Azure SQL Database server. So this is the server, not the database on the server. And for authentication, we could use SQL authentication, but let's use the Azure Active Directory account that I set as the administrator. And now I'm logged in to the Azure SQL Database server in Azure. And the database has been created. Let's expand the tables. And of course, there aren't any, because we don't have a database structure for the application yet. We can deploy that by using a script or by setting up continuous integration, which we'll do later. But next, let's see how we can deploy the web app and database from Visual Studio using Web Deploy. Now let's see how we can deploy the app and database right from Visual Studio using the Publish feature. So inside the Publish wizard for this app, I'll choose Azure, and this is a Windows-based app service we're deploying to. So because the source VM here and the target VMs in Azure are both Windows-based, the underlying deployment technology will default to Web Deploy. If you choose to deploy using Zip Deploy, or you deploy to a Linux-based app service where you have to use Zip Deploy, in both those cases, you have to run the database updates yourself using a script, a DACPack file, or as part of a release pipeline. I'll select the resource group with the new app service I want to deploy to, and click Finish. That'll generate the basic publish file for the application code only. Notice we have this warning about basic authentication being disabled for the app service. Remember from earlier in the course that we need to manually enable basic authentication on the app service in order to publish the code from Visual Studio. So let's go to the Azure portal where I'm already inside the app service that we're going to deploy to. I'll go to Configuration and turn on SCM Basic Auth Publishing and save these changes. Now we can go back to Visual Studio and continue with the configuration. Let's modify the publish settings to include the database deployment. We do that by adding a service dependency. Visual Studio has already picked up that there's a SQL Server database involved in this project, based on the appsettings.json file. But we don't want to include that here, because it points to the local database. So let's ignore that dependency for this profile. Now let's add a new service dependency. There are several Azure services listed here, like Azure Storage and Key Vault. We want Azure SQL Database, so I'll click Next. And because I'm logged into Visual Studio with the same account that's an administrator in Azure, the Azure SQL Database we created earlier is showing here, and it's highlighted. Click Next, and I'm going to choose the connection string path that's the same one as in the appsettings.json file. That way, this will get added to the app service configuration connection strings during deployment, and it'll override the value in the appsettings.json file. Next, we need to fill in the SQL Server user that was set up as an admin when we created the Azure SQL instance. This will get added to the connection string value here, which will get added as a connection string on the app service. And you can see my secret password here in plain text. If you prefer, you can have the connection string information saved in Azure Key Vault. We'll leave the default of using app service. Now let's click Finish to complete the wizard. Let's close this, and we need to do some more configuration of the publish settings. Click on Show All Settings. Here you can select the release configuration for the build, the target framework, and the deployment mode. Framework Dependent produces an application that only includes the app itself and its dependencies. It doesn't include the .NET runtime. Whereas choosing Self-Contained will include the .NET runtime and libraries, as well as your app and dependencies. So it can be run on a machine that doesn't have .NET installed. But since we're deploying to app service, we know the dependencies we need are already there, like the .NET runtime. The target runtime defaults to portable, which means the app can run on x86 or x64 machines, and will get just-in-time compiled at runtime. We could change this to the specific target architecture we're deploying to, but for small applications like this demo app, it shouldn't make much difference to performance to leave the default. Under File Publish options, we can check to remove additional files at the destination, which does just like it says, deletes all the existing files in the target folder. Under Databases, we want to check to use this connection string at runtime, and make sure we have the Azure SQL Database connection string selected. Then under Entity Framework Migrations, this is how we get Web Deploy to update the target database, by checking to apply this migration on Publish. And again, make sure we have the right connection string selected. We'll leave this default selection to install ASP.NET Core logging, and let's save these changes. Now we're ready to publish the app code and Entity Framework migrations. It'll take a little time to do this, but along the way you can see that it's executing a command, .NET EF Migrations Script. This is the equivalent of the script-migration PowerShell command that you saw earlier, and we'll look closer at this shortly. Web Deploy is packing up the files and deploying them to App Service and running the database changes on the target database. When it finishes, the browser opens up and let's navigate to the Expenses page. Now we have some data in the database, and we obviously have the tables in the database. Let's drill in. And there's the lookup values from the expense types table. Let's go into SQL Management Studio, where I'm still logged into the remote Azure SQL Database server. And the database is here. If I refresh the tables, there's the 3 tables that got created, 2 for the entities and 1 to track the Entity Framework Core migrations that have been run on this database. We can run queries and see the data in the database here. Now let's go back to Visual Studio and look at the output from the publishing. If I scroll up, let's look at the step that built the migration script for the database. That's here near the start. It's the .NET EF Migrations script command, and the parameter's no build because the publish process is already building the project. Then this parameter idempotent. This is important because it generates the script in a way that will check which migrations have already been run by using the migrations history table in the target database. And it'll run any scripts that haven't already been run. Basically, it includes all previous migrations in the script and checks the target database for each one. This is useful when you're not sure what the last migration applied to the database was. Then there's a configuration parameter, an output parameter that will output the SQL script to this folder. And finally, the class that contains the DB context information that Entity Framework Core needs. You'll see me use this .NET command again later when we configure a GitHub Actions workflow to deploy the Entity Framework Core migrations. Let's see what this idempotent parameter does. And to do that, I'll run the PowerShell equivalent of the .NET EF Migrations script command, which is script-migration. You can see it first checks for a table called migrations, and if it's not found, it creates the table. Then it checks the migration table for the individual migrations using their identifiers, and it only creates or changes objects if the particular migration hasn't been run already on the database. You can then copy this SQL and go to SQL Management Studio, create a new query on the database, and run the SQL. If you're planning on using deployment slots, that's probably the approach that you would take. And this also gives you a chance to look over the changes that will be happening to your production database. And you'd probably want to do a manual backup before you execute this in production. Before we move on from here, let's just go back to the Azure portal, and I'm inside the web app where the code was deployed. Let's go to the Environment Variables section and the Configuration Strings tab. Web Deploy created the connection string called Project Context, so this will override the connection string in the appsettings.json file that was uploaded, and that means this value will get used by the C# code. It's storing the URL to the Azure SQL database, and the credentials are stored in plain text. So before we set up a deployment pipeline, let's talk about some other ways you can connect to Azure SQL Database from your app service. We'll do that in the next clip.